Hello, whoever's watching. Today is Saturday, March 22nd, and I'm going to do another LeetCode daily challenge. So, I'm a little bit late today because I was being a construction worker today. Um, did some cement work. Uh, but yeah, let's start. Haven't even thought about LeetCode today, so this is going to be interesting. Okay, 1976. It has a very low acceptance rate, so I'm kind of scared. Probably won't be able to do this one, let's be honest. But let's start. Okay. So you are in a city that can. Okay, wait. Number of ways to arrive at destination. You are in a city that consists of n intersections, numbered from 0 to n minus 1, with bidirectional roads between some intersections. Okay, the inputs are generated such that you can reach any intersection from any other intersection, and that there is at most one road between any two intersections. Um, there is at most one road. Okay, okay, okay. Wait, so just what I read so far, let me draw this out. If we have a city here and another city here, they're joined by at most uh what is it? At most one road between those two. We will never see this or this, right? Um that that being said, a city can have many intersections. It can have many roads pointing to other cities, but it just can't have like another road pointing to the same one, right? Like this will never happen. Okay, that makes sense. And then I read something up here. The inputs are generated such that you can reach any intersection from any other intersection. So that means like this whole idea of the connected component, it's just one connected component, right? Like we'll never see a city that we can't go from this city, like city one, to city two. It will always be possible, which means there has to be a connection, right? Whether it's a direct connection or an indirect connection, that you can take the path that will lead there. So that's what it means so far. Um, anyways, let me keep on reading. So you are given an integer n and a 2D integer array roads where roads I, U, V time means there is a road between intersections. Okay, okay. So intersection U to V, these are the vertices, right? It takes time to travel from one city to the other using this road. Okay, that makes sense. You want to know in how many ways you can travel from intersection 0 to intersection n minus 1 in the shortest amount of time. Sorry, give me one sec. Okay, that's interesting. It's weird that they want how many ways. Usually it's just like, oh, what is the shortest amount of time? And to do like shortest amount of time, that means these are edge weights, right? I think we can just use um, Dijkstra's. And what Dijkstra's will do is only if we see something better. Okay, wait. First of all, Dijkstra's is going to have like an array of like a bunch of nodes. Are we given a start? Let me see. Oh, where do we start? Oh, from intersection 0. So that's actually very important. So that's something that we need to mark, that the start is equal to 0. And then usually we can have like, is it like a cost or maybe like a time, right? And and these are just going to represent like cities. I guess city 0, since we start at it, it can originally have a time of 0. But then if we start without doing any Dijkstras, um, it should all be infinity, right? Like city 1, city 2, city 3, all the way to city n. Um, we should expect originally to be infinity. And then we're just going to run Dijkstras, which I might be a little shaky on, but I'll try. And I think every single time we reach a node, we can keep track of the cost. If the cost was better than whatever is in this like array, then we can like keep track of the number of ways. And then okay, so if it's less than sorry, like if there's like a current cost and it happens to be less than our time at the node, right? Then we want to update time. Oh, and then maybe it could be infinity and 0. Maybe it could be like a tuple. Um, and this tuple will be the time is on the left, and on the right, it's how many ways, right? Number of ways. Now, if the current cost, or yeah, current cost is less than the time, we can update the time to the current cost, right? This will be the current cost. And then we could update the number of ways to back to 1. So that's one case. And then another case we need to say is, what if cur cost is equal to the best time? Because everything in this time array, how Dijkstra's work is everything in the times array was the best, right? The best it could possibly be. Um, so okay, so time at the node 0, right? Because now we have it's a tuple and we only care about the time. So if it's equal, then we want to update time um, update time node 1 plus equals to 1, right? We just up the count. Wait, sorry, what is destination? Because I know that we start. You want to know in how many ways you can travel from 0 to n minus 1. Oh, I see, I see. So I guess that would be n minus 1. And then just something to keep in mind, we just want to return the best, right? Time at node, which is n minus 1, and the number of ways. So it's going to be 1, and then mod by this whatever mod they want. Okay. I think we're just going to start that. 1, 2, 3. Let's write a plan. Dijkstra's algorithm. So keep track of best time with the number of ways. So it's going to be looking like a tuple, which is going to have best time, number of ways. I don't have to write this out explicitly. In the end, I just want to return the best time at n minus 1 at 1, because that's the number of ways, mod by, what do they want? 10 to the 9 plus 7. 10 to the 9 plus 7. Oh, and then something that we want to do is our start is 0 and our, maybe I call source, and our destination is n minus 1, right? And then just to be super clear, they say there's n intersections. Does that mean there's n minus 1 cities? So for example, there's 7. Does that mean it's 0 to 6? Yeah. Okay, so maybe I'll just write that down. There are n intersections means city 0 to n minus 1. Okay, I haven't done Dijkstra's in a while. I think I definitely need to set up some sort of array. Maybe I'll call like best times. It can be something that originally is super big, right? Infinity. And it's just like a one-dimensional array. And it's going to be of size n. And then I could say best time, since we are starting at our source, right? Our source is 0. So best times at 0 is just 0. It costs nothing. Oh, and then let me further clarify that best times is going to be a one-dimensional array of tuples that consist of the time and the number of ways, right? So this needs to be a tuple like so, and the number of ways needs to be updated. Well, honestly, I don't know. Maybe I'll just do this. It doesn't really matter. Okay, and then there's one way to get to 0. Does that make sense? Yeah. Okay, I won't think of edge cases for now because I'm thinking what if n is 1, but I'll think of it later. Let's just try to fix this first. Maybe I'll write it down. What if n equals 1? Okay. Okay, so I guess there's 0 ways so far because we don't know. And then we could say best times 0 is equal to our own thing, which is going to be a time of 0 with number of ways is only 1. Right, let me just print this out really quick. Just checking. Yeah, 0, 1, everything else is infinity, 0, infinity, 0, infinity, 0. Cool. So I think Dijkstra's is similar to BFS. Just have a queue that has a deck. And in the beginning, the deck can have the source, right? And we start at 0. Interesting. Okay. Because I think usually you can just put. You can just put the number of ways in this deck. But the only concern I have is when do we stop? I think I'll do this and then keep the number of ways in our array. So we'll just do all our processing in the queue, and then I'll just trust that when it's time, our best times will always have the best time. So when we finish doing BFS or Dijkstras, we know that this will contain the number of ways to travel from 0 to n minus 1 in the shortest amount of time. Okay. Okay, I'll just start with this. This is the city. Oh. Wait. Oh, I'm crazy. I mean, before I even think about BFS, we want to like populate or like create a graph, right? To represent the road structure, which I haven't really thought about that. Maybe I can just see something. So it's bi-directional. That's fine. So I'm just gonna do create graph representation using an adjacency list, which is a default dict of a list. The key can be the city, and the value is going to be a list of a bunch of neighboring cities. Yeah, so we just do, what is it, roads? So for UVO. Yeah, I mean, they tell us here UV and time, right? So UV time, UVT in roads. Sorry, so it's going to be a list of, it's going to be a list of the neighboring city with the time that it takes, right? Graph at u dot append VT. And since it's bi-directional, like if we, okay, that means if it takes 5 minutes to travel from 4 to 0, that means it also takes 5 minutes to travel from 0 to 4. 2 ways, right? So we just need to do graph at v. What am I doing? Graph at v dot append ut. Okay. Okay, so I guess here is our like BFS like Dijkstra's thing. We have a queue. Do we need visited? Yeah, I think we also have a visited. It's a set starts at 0 as well. While queue. Current city is equal to q pop left for neighbor city and time. Oh. I think the part of Dijkstra's that's different is that we always keep track of the time that we spent, right? So that's no problem. It's just going to be city and the city and the current time. And the current time is just going to be building. So current city, current time. It's just going to be like a tuple. This. Okay. The neighboring city and the time in graph at the per city. So if we started at 0, it's going to give us this, this, and this, right? Okay. If the current time plus the t is less than, isn't this when I do like my possible cases right here? So we can just do cases. Current time plus t is less than the best times at to get to the neighboring city, right? To get to na city at 0, because that's the time. If it's less than that, we do something. We also want to check if current time plus t is equal to the best times na city at 0. So two things to check. So this is the first thing. If this is true, that means we found a better time. So we could just do best times at the neighboring city is equal to current time plus t. It's two things, right? It's going to be the time and the number of ways, and there's only one way to do that right now. We reset it. Else if cur time plus t is equal to best times at the neighboring city at 0, we found another way to get the best time. So we just update it, right? Best times at neighboring city at 1. Wait, best time at the neighboring city, which will bring us to here. And then we want the time, which is 1. And we want to, oh no, what? No. It's right here. We want the num ways to be updated plus equal to 1. We found another way to get the best time. Okay. Oh, and then I guess we don't, I don't think we need visited then, right? Does Dijkstra need visited? It's always gonna put the best stuff. Yeah, I don't think we need visited if we just check for this best. And then like I said, right, all we need to do is just return when we're done processing Dijkstra's. Oh, we have to add it to the queue. Just either case we need to add to the queue. queue.append. And what are we going to add to the queue? Uh, the neighboring city with the current time plus 2. Right? Both cases. And we just want to return the best times at n minus 1. But we want to just return the number of ways, which is the first index. Oh, and then mod, right? Mod by 10 to the 9th plus 7. Okay, let's go ahead and run that. Okay, that worked. Am I printing anything? Nope. Whoa, what? Wait, if I'm running, maybe I'm running Dijkstra's wrong. Because I thought I coded it up pretty good. Just a 1D array. I mean, it worked with the smaller cases. Okay, maybe we do need a visited set, but that's interesting. If we found a better time, wait, this could be it. N could only be 200. That's not bad. But I'm getting wrong answer when an N is only like 34, and that's not even the max. So I'm not doing something right. Probably my Dijkstra's is off. It can't be this simple, right? I don't know. I don't know. Let me try visit it. I don't think we do that though. Oh, yeah, but I don't think so. Because we want to possibly visit neighbor again. It might be better. Weird. Whatever. Visited dot add this neighboring city. Visited add this neighboring city. If neighbor city not in visited, just do all of that. I don't think that's right. No, it needs to keep visiting. What the hell? I'm not sure. This is interesting because, damn, I feel like I've exhausted what I know. So I am going to ask AI. I am going to have to ask AI. This. Here is my code. It passes half of the test. I'm getting a time limit exceeded though. How can I make this code more efficient? Oh, oh, wait, wait, wait. Wait, wait, wait. Okay, okay. I know that's cheating. I already read that. But the deck is okay. Um, when we append, we just need to append left, right? Or we'll do the min heap. Maybe I'll do that. But I if it's better. Wait, wait, wait. What? I'm gonna try this, but maybe not. No, a pen left and a pen right is only for like a 0-1 BFS. So this will still not work. Yeah. Okay, 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 okay. So let me just read. They're saying instead of a deck, maybe we should use a min heap. Okay, let's do that. How would I do that? Min heap, heap queue, heap push into the min heap, 0, 0. Okay. I mean, we're just gonna comment this out for now. This is just heap q dot heap pop from the min heap, so it's gonna give us these two things. We do that. If it's good, then we can go ahead and put it in. Wait, what? But we're still gonna be checking it the same amount of times, right? Like, I don't. Like in the end, if we do things 100 times, even if we put it in a min heap, we need to do it 100 times. Oh. Oh, but we only want the most efficient ones first. So that maybe in those 100 times, if the most efficient was done earlier, we don't have to run through 99 times because it will never get through this. Okay, okay, that makes sense. That makes sense. So we always want to prioritize the smallest. Okay, min heap. Heap queue that. And then we just need to add to our min heap, right? So heap queue dot heap push into the min heap. Push this stuff in. Same idea here, except... Oh, exact same idea. Yeah. Yeah, okay. Shit. Don't need that anymore. Don't need that anymore. Let's run that. While min heap. While min heap. Oh, whoa. I never populated my min heap, but I probably deleted it. Heap push into the min heap. The city and the current times 1, right? Or 0, 0. Sorry. Yeah, let's run that. Sorry, I'm getting flustered. Oh, that's still not good? Still not good is crazy. Okay, let's see what AI says. Yeah, just get a priority queue. You want to heap pop from the priority queue. If we found a longer path, skip. Huh. Why would it do that? if the current time is greater than times at the current city at 1, right? That's what stores the time. Then they want to just continue. Okay, does that help? This is best times. Oh, wait, this is time and number of ways. Am I doing this right? Time and number of ways. Number of ways goes up. Best time, 0, right? Because that's the time. If the current time is greater, then just continue. Okay. What was I doing? Huh. I don't know. Wow. Damn. Not even that worked. Okay, I spent too long on this. Um, yeah, let me just look at the solution. Yeah, Dijkstra's, man. Why isn't Dijkstra's working? Floyd Warshaw's algorithm? Whoa, whoa, whoa. I know Warshaw's. Warshaw's is like, you have an intermediate, yeah, an intermediate node. How can you use Warshaw's on that? I have no clue. Okay, okay. Let me look at Dijkstra's. Like, what am I doing wrong? Oh my god, this is too much. Fuck. Fuck, 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 fuck. What am I even doing? Is it this one? Right? Yeah. Oh my god. I feel like that's exactly what I was doing, based off of what that says. Oh my god, let me just look at the code. What the fuck? Okay, we building the graph. Yep. Min heap. Okay, I didn't know that until I got the thing. Shortest time. Yeah, I'm doing shortest time, but I'm doing it as a tuple. Path count. Whatever. Shortest time 0. Path count 1 way to reach node 0. One way to reach node 0. Oh, do I need to do this? See if this works. If cur time is greater than the shortest time a cur node. Oh, wait. Min heap in the cur time. Wait, 0. Yeah, I did that. Oh, sorry. 0, 1. One way to reach node 0. Number of ways, yeah, to reach node 0 is 1. Oh, shit. Yeah, so that actually, everything should be fine. I don't really get this one. If current time is greater than shortest time at cur node, which is best time at cur 0, and best time at 0 is the time. Then continue. Or maybe I'm updating it wrong. We found a better time. I'm only looking at time. So I'm only looking at the 0, right? It's very similar. Damn. Yeah, it's probably just like an implementation error. I'm not understanding something. It's annoying. Okay, wait. Best times is times and the number of ways. So if the current time plus t, is that what they do? Current time plus the road time, yeah, is less than the shortest time, which is the best time at the neighbor node. I mean, they just used two different arrays. Then the shortest times this, the path count is equal to the path count at current node. Oh my god, that's so annoying. Let me just ask them. Here is the solution. Here is my version. It doesn't work. Gives to a time limit exceed. Why and how can I fix? Oh shit. Oh shit. Only if it's better than we push. if if it was the same, we don't need to recheck that neighbor city. Oh shit. Oh, also I don't know why this doesn't work. Interesting, I don't know. What is going on? Wait, why isn't it even passing the beginning? What did I do different? What? This is so fucking annoying, man. What am I doing so wrong? Ah, right, that's exactly the same bug. Except they did a check right here, but that didn't even work for this. Okay, you know what? We just do what they say. Actually, I want to do my way, but just follow them. Cur time, cur node, heap. Why doesn't this work? If the current time, right, city and time is for the min heap. Min heap is the city and the time, and the city and time of the min heap is both starting at 0. Okay, they say if the current time is greater than best times at the current city, but best times will give two things. It will give the time and the number of ways, so 0. Best times at 0. If current time is this, then we could just continue. Why doesn't this work? I don't know, is it like expecting me to do this? Then for the test case, let me remove this. Okay, it works when I do that, but for some reason we're not going to do that. Let me keep going. Okay. For neighbor and time and graph, found a new shortest path, right? If the current time plus road time, which is here, is less than the best time, nay city 0. Okay, then let's update the best time, nay city, to be the current time, this, and then the oh, why is the path count at the current node? I don't get that. Reset path count to match path count at the current node. Huh. Why do you want to match? Huh, you want to set it to the previous. How many ways to get to the previous? That's what are, oh, interesting. So it's updating the counts a little bit different. It doesn't just do one. It's now this gets a little bit tricky. It's best times at the current city. We want the number of ways, so that's going to be index, the first index of that. Okay. Maybe that's why they kept it separate, because this looks disgusting. Okay, then we can push into our min heap. The oh oh oh, and this is so off because a min heap, if it's a tuple, it's gonna only prioritize the city. So the min heap actually needs to be current time and then city. Um, fuck. Current time, current city, heap push, current time, current city. Oh, I don't understand this whole thing. Like, huh, that's so crazy. If I found another path that's just as good, let me get all of those paths to get to the current node, to get to the like current city and add it to there. Okay, that makes sense. The best times at one plus equals to the best times at the current city. So interesting at one. I would never have done that. Okay, let's run that. Interesting, interesting. Interesting. I'm ass. I fucking suck. Okay, what are red flags in this problem that I struggled with very bad? This is a big red flag right here. Min heap. Use min heap for Dijkstras. And then obviously, like when you sort an array, like min heap at 0 is what determines sorting. So make sure cur time is at index index 0, right? I never had this. Like if I don't have this, does it still work? Okay, okay. At least it doesn't change anything if I do this or not. Originally, I never thought of that, and I don't think it makes sense to me because if you're doing min heap, it's always the best, the best, the best. Yeah, so it should be fine. Um, I'll probably have to sit down and think about this. I was right that there's two cases where we do something. What I was wrong about is we shouldn't be adding to our heap when they're equal. And then also like when it's time to update the best times, right? Because we want to update the best time and then we also want to update the number of ways. Why is the number of ways just how many ways the best the number of ways to get to our current city? Like I don't really understand that. I don't understand why we don't just reset it to one. Like, hey, we just found. Oh, okay, wait. Actually, I think my thinking is okay. My thinking is okay to do all this updating stuff every single time. So when we go to 0 to 6, it will literally it will literally say, okay, that is one way. And then it's going to say, oh, that was another way. And then it's going to go 2, 3, 1, 1. And it's going to say, okay, that was another way. So I'm going to have three ways. But to get to that result, it was very taxing. Versus, ah, versus we just look one back, but I can't, I can't think about it right now. I don't know. I'll have to sit down and see why it's inefficient. But to make it better, we only care about the last notes. Anyways, I'm rambling. It's gone too long. This was a frustrating problem. Like I feel like I got some idea. I didn't get the solution, obviously. I just got like some idea. Use Dijkstra's, and then there's just like two cases. But then what to do in those two cases are different than what I came up with. Okay. Anyways, hope you guys enjoyed this video. It would be crazy if anyone's watching, but just documenting my progress. Um, yeah, time and space. Linear, right? Linear, but add a log n. Why do we add a log n? Oh, because the priority queue, the min heap.